In this video, we're going to be looking at a typical single-phase electricity supplier into a domestic property. We're going to look at the distribution cables and transformer, the phase, neutral and earth, the main fuse, the electricity meter, the isolation switch, the consumer unit, as well as the RCDs and MCBs. Some slight variations, and these components may look a little different between the countries, but essentially it's very similar. Color codes for this video that may be different from your local regulations. Remember, electricity is dangerous and can be fatal. You should be qualified and competent to carry out any electrical work. So the electricity is generated far away at the power station. The electricity leaves the power station and the voltage is increased in a step-up transformer, where it will then be distributed over long-distance transmission lines. We generate and distribute AC alternating current because it is more efficient and convenient than DC direct current. Once it reaches the town, the voltage will be reduced in a substation step-down transformer. From the substation, the electricity will either be distributed locally through overhead or underground cables. Depending on the local design and the voltages being used, a home might be connected directly to a small transformer located close to the property, or alternatively, a group of houses will share a larger transformer. The electricity is distributed in 3 phases, but in this case we're looking at a single phase installation, which means the property is connected to just one of these 3 phases as well as the neutral. Each house in a street might be alternately connected to a different phase, or different streets might be connected to different phases. This is just to try and balance the demand on the transformer. A smaller service cable comes off the distribution cable and will feed the property. This service cable will again be overhead or underground depending on the local installation. The service cable contains the phase and neutral wires. There's also a metal protective sheath around the cable in most cases, especially if it's buried underground. The service cable comes in, the electricity is going to flow through the phase, pass through the main fuse, then through the electricity meter and then into the consumer unit. Inside the consumer unit we first have the main switch or main double pole isolation switch. This controls the supply of electricity to the rest of the consumer unit and therefore all the circuits feeding the property. This switch is not automatic and must be manually flipped to cut the power. This switch will disconnect both the phase and the neutral line together. The cables typically enter the main switch via the top terminals into each of the MCBs, which just makes the installation easier rather than having a lot of cables. The MCB or miniature circuit breaker controls individual smaller circuits. On the other RCD, maybe we have one for the stairwell lighting, one for the upstairs lighting, and one for the downstairs plug sockets. These switches will quickly and automatically trip to cut the power, but they also need to be manually reset to restore the power. The MCB protects the circuit in 2 ways, overload and short circuit. The MCB is rated to handle a certain amount of current passing through it, for example 32 amps for the plug sockets. If this value is exceeded on that circuit, for example by gradually plugging in too many things, then the MCB will trip and cut the power to protect itself. The other protection it offers is short circuit protection. In the event of a short circuit, for example the live touches the neutral, then the circuit is bypassed and there may be a large and instantaneous increase in current. This will create a magnetic field inside the MCB which will cut the power to protect itself.